Hey everybody, Miss Glad here. I am going to walk you through a review for the systems that we've learned these last few weeks. We are going to graph, we are going to look at different solutions to a system using elimination and also substitution. So grab your sheet and join me. You can fast forward, pause, rewind at any point. Hopefully, this helps if you have been out or you might just need a little bit more practice. So let's take a look at this first one. What are the solutions to the following system? And so looking at this one, I can directly see that my system, my bullseye that I see here is a nice intersection at exactly 2, 0. So there's one solution here. And again, it is found at 2, 0. Letter B, I'm looking at this system and I notice I've got a blue line and a red line. They are completely parallel. They will never touch. And so that there are no solutions to this system. The shortcut for that is a 0 with a line through it. That means no solution. Or you could write no solution. Either way works. For letter C, here we've got two lines that are graphed on top of each other. So they are completely clones. They are identical. And so when that happens, we know that they're the same line. And so they have infinite solutions. So infinite solutions means that every single point on them match. That is our first question. Moving on to our next question here, let's take a look at number 2. Solve the systems using graphing. So for this one, we've got to think first of all, I'm looking at both of my examples and I see that the system is set up for y equals. And so we've got to identify our slope and our y-intercept. And so it would be good to write this, be thinking about y equals mx plus b. And I know this goes way back to, January when we discussed slope. Remember, slope is always connected to our variable x. That's our slope. And the slope just tells us how steep our line is going to be. I use slope dude to help me out, positive, negative. And the other number that we want to be concerned about is our startup, also known as the y-intercept. So let's take a look at the example here on the left. Y equals negative a half x plus 2, y equals x minus 1. And so what I need to do is I need to graph both of these on the same graph, and so that I can see where the point overlaps, known as our system. So this first part here, I see that the measure of my slope m is negative 1/2. I'm just going to write it over here. So a slope of negative 1/2 tells me that I'm going to be going down 1 and to the right 2 to find my next point. I'm going down because it's a negative slope. And the startup, my y-intercept here on the y-axis, I'm going to start at a positive 2. So my y-intercept is right here at 2. And now I'm going to apply my slope. I'm going to go down 1, right 2, down 1, right 2. And what I should do is I see these points here. Those look good, but I'm going to unwind my slope and I'm going to go the opposite way. I'm going to go up 1, left 2, up 1, left 2, just to continue so that I can get a pretty decent line here. Now I'm going to do my best with my mouse to connect. Oh, not bad. Okay, so that first line has been complete. Now I'm going to switch my colors up and I'm going to do my second line. Second line, slope. Well, what's connected to my x, my coefficient, is actually a 1. And so my slope for this one, if it is a whole number, we simply put it over 1 to change it to a fraction. And so my slope is 1/1. Now that is a positive slope, so I'm going to go up 1, right 1, up 1, right 1. What is my startup? My y-intercept is at negative 1. So I know that I'm going to take my line, I'm going to start it right down here at negative 1, and now I'm going to apply my slope. Up 1, right 1, up 1, right 1, and I see that I have created my bullseye right there. I'm going to go ahead and connect my points. I don't really need to extend it any further because right here, I'm just going to highlight this, is we have our bullseye right there. and that is exactly at location 2, 1. So to finish off your answer, you would need 2, 1. There it is. Okay, now for your second question, I did this first one. Again, you're going to need to identify your slope. So the measure of my slope in my first line here is a positive 1/3. And my y-intercept, the b, you are going to start at -1. So your startup is right here. Okay, looking at my second line, I have a slope. My m is actually connected to x here. It's a -1. And so I'm going to go down 1, right 1. And my startup here is at +3. So I'm going to change that color to red. +3 is the startup on that line. So go ahead, use your slope and continue to finish that one off. Moving on to question 3, I've got some substitution questions. Substitution can be kind of tricky. And so let's go ahead and set these up. Now notice that for letter A, I've got y equals 2x plus 10, y equals -2x minus 6. Now I could use a graph and graph that. However, the graphs that we have aren't quite large enough. Look at your y-intercept at 10. So you're probably going to be off the graph. So another way that we can use this is we can actually use substitution. And here's what I know. In a system, we are looking for 2 points working together. We are looking for our x and we're looking for our y. So where do these lines overlap? Now, notice that the y's are the same. Y equals. So whatever y is, it's the same. And then notice over here that 2x plus 10 is going to have to be the same amount as whatever -2x minus 6 is. These two expressions that I've circled must be equal to each other. And so what we've got to do is we've got to set up our equation. I'm going to set up 2x plus 10. And I've got to set that equal to -2x minus 6. Because by setting these equal, we're going to find our x. And once we find our x, we know our y. So right here, I'm going to go ahead and I see that I forgot my x. I'm going to squeeze that in. There we go. Now, when I solve with variables on both sides, I've got to start with my variables first. And I like to always choose the smaller variable so that I can avoid some negatives if possible. So I'm going to add 2x on the right to cancel that. And then I have to do the same thing on the left to maintain balance. Now I'm going to draw my horizontal line. My 2x's eliminate. Now be careful over here. It's not just a 6. It's actually a -6 balancing. And it's balancing with 4x plus 10. Okay, now to get that x alone, we just go ahead and finish this as a 2-step equation. So I'm going to undo the addition first. I'm going to go -10 on the left, -10 on the right. I'm going to draw my horizontal line. My 10s cancel. And check it out. This is going to turn out pretty nice. 4x equals -16. Divide by 4. I get x equals a -4. Okay, so the first piece to our puzzle has been complete. X is -4. Now that I've found my x is -4, and this is where a lot of people get confused. They're like, I don't know how to get the y. Well, we've got to use this now. We've got to input that in right here. If I know x is a -4, I'm going to put a -4 in there. That's supposed to be a parenthesis. And here, oopsies, I can put a -4 right in there. A little bit messy, but so I've input a -4 where the x's live because we want to find our y. Now, it doesn't matter which equation we use, but we have to use one to calculate our answer. And so here on this top equation, I think I'm just going to go with this one. I would take -4 times 2, which gives me a -8, and a -8 plus 10, which would equal a +2, right there. So -8 plus 10 gives me a +2. So I now know that my y solution right here is a 2. And if you didn't trust that, you could do the same thing down here. 4 times 2 is a positive 8. 8 minus 6 also gives you 2. So I've double checked to make sure that that works. Now for our second one, I'm going to get you started on this one since I did one with you. Here, this is substitution because you notice that this y is isolated. It is worth exactly 3 times x. And so remember, we are looking for the x and the y value that works in both solutions. This are both equations. It's called a system. And so I'm going to take this 3x right here. And what I'm going to do is I'm going to replace it with this letter y directly above it. So I'm going to replace the 3x with the letter y because then we can get an equation with all x's. And our goal is to get the x alone and then find out our y. So first step, I'm going to drop that in. So I've actually got 4 times x plus 2. Now instead of the y, this is the part that I'm going to input. I'm going to use my parenthesis to drop it in, 3 times x. So here it is, 4x plus 2y, but instead of the 2y, I've got a 2 times 3x. All of that equals 10. I'm going to put my line in, and now I'm going to go ahead, and I'm going to keep on going. You're going to multiply 2 times 3x gives me a 6x. So I've actually got 4x plus 6x, which equals 10. Now, I think I'm setting you up in pretty good shape here for you to get your x alone. Once you find your x, you can put it back in right here to get your y, and that problem will be complete. Moving on to our next one, problem 4. Problem 4 is elimination. And problem 4, I've got a couple of them. I've got what I would call an easy one, and then I've got one that takes a little bit more work. So let's start with letter A. So when we use elimination, our goal is to eliminate a variable. And so as I'm looking at these, I'm looking at my x's, I'm looking at my y's, and I notice that with doing no work at all, I can combine my variables together and notice that immediately my x's eliminate. Check it out. Positive and a negative 4x eliminate. And so then I'm going to go ahead and I'm going to combine my y's. Negative 2y, a positive 8y gives me, 6y, which equals a negative 36. Divide by 6 on the left, divide by 6 on the right. Y equals negative 6. So right here, I have come up with my part of my solution pretty quickly. I know that the y has to be a negative 6. Now, I still need to figure out what x is going to be. And so I have 2 options. I've got the top equation or the bottom one. Doesn't matter which one I use, but where you see that y, right here is where a negative 6 is going to go in. So a negative 6 is going to go in right here, or it's going to go right here, negative 6. And it doesn't matter which one, but we have to use one of them. And so I think I have a tendency to stay away from negatives. Look at all the negatives in the top one. So I think I'm going to choose the second equation to plug that negative 6 in for my y. And so I'm going to write it just directly below here. It will turn into 4x plus 8. Now, instead of my y, I'm putting in a negative 6. So I'm going to use my parentheses. So times the negative 6 is how that will look. And all of that is equal to negative 24. So we are back to a 2-step equation. 4 times 6 is negative 48. That is balancing with the negative 24. And over here, don't forget, I still have my 4x. So our goal is to get this x all by itself. And so to do that, I've got to remove the subtracting 48. And the easiest way is to add the inverse. So I'm going to do plus 48 on the left. And then I'm going to do the same thing over here on the right. I'm going to add 48 on the left. Right. Whoops, there's my 8. Now, in order to cancel these out, okay, I see that I'm going to be sitting with a 4 times x equals, and now here I've got 48 minus 24, which gives me a positive 24. Oh, this is going to turn out nice. Divide by 4, x equals 6. So right here, I get a nice positive answer. I get my x equals, oh, you know what? I made an error. Let me come back here. As I was looking at my work, I'm going to pause this real quick. No, all good. X equals 6. We did that exactly correct. So right here, my x equals 6. Kind of got confusing here with those negatives. So just don't be afraid to show your work and kind of write that out. I checked both equations and this is correct. The second elimination one is a little bit more involved because as I'm looking at it, I notice that the x's don't eliminate naturally and the y's do not eliminate naturally. And so I can use multiplication to either make the x's cancel or the y's. I kind of have a choice here. Now, the x's, we could make them cancel. If this is a 10x, I could make this a negative 10x. So that would be one way. Or the y's, what I like about the y's is it's already a positive and a negative. And here it's a negative 7, so I would just need to make this y a positive 7. Now, in order to do that, I'm going to pick this top equation, and I have to multiply all of it times 7. That way, I can get my y's to cancel out with a positive and a negative 7. So now, in order to balance this, we have to properly equally share or distribute. So I'm going to take times 7 times 7 times 7. And so when I do that, my new equation is going to be transferred. I'm going to write it right below. I'm going to do 7 times 5. This will become a 35. Sorry, it's hard to write little with my mouse here. And then 7 times y gives me a plus 7y. And all of that is balancing with 7 times 9, which is a 63. So I can kind of temporarily forget this top equation because what we've done is we've transformed it now, and I'm just going to put a box right here to make these two equations work together. And so if you notice right away, we are able to eliminate these y's. That was our job. We wanted to eliminate them. And so now we've done that. So let's go ahead and I'm going to add my 10x and my 35x together. That gives me 45x, and that is exactly equal to negative 18 plus 63. Or if I go 63 minus 18, oh, look at that, gives me a positive 45. Divide by 45, divide by 45, I'm going to get my x alone. Looky here, x equals 1. And so that wasn't too bad to get that alone. I've got my x is 1. So now you just have to finish to find the y. And so I'm just going to take maybe I'm going to take my little eraser here. Maybe not. And what I was going to do is wherever you see an x, I'm going to put a 1 in. I could use this equation. So it's a times 1 here, or it's going to be a times 1 here, or it could be a times 1 here. I can use any one of these three equations to find my y. I just simply put a 1 where all the x's are. Now, I think the simplest equation to use is this top one, because check it out, it was 5x plus y equals 9. So if I put a 1 in for my x, 5 times 1 is 5. 5 plus y is equal to 9. And so I see, if I get the y alone, I'm going to subtract 5, y must equal 4. And there we go. We have our solution. Last ones. We've got a word problem here. And this word problem is one that we're going to have to read. And we're going to talk about what does it represent. We'll show our work and we'll find our solution and explain what it means. So there's a lot of pieces to it. So here it says a restaurant sold tacos and burritos. Tacos are $2 each and burritos cost $1. The restaurant sold 48 items for a total of 86 bucks. How many burritos were sold? So right here, here's what I'm going to say. I'm going to say T is going to stand for tacos. And obviously then B is going to represent the number of burritos. Okay, and so with that, let's take a look at what's going on here. So we know that we've got a combo, tacos and burritos. Tacos are $2, burritos are $1. So this is important right here. Together, they sell 48 items. And so immediately I know that these two items together are going to equal 48. So I'm going to set up my very first equation to say T tacos plus the burritos together sold make 48 items. Okay, so that one wasn't so bad. Now, the second part about is money, the cost. Together, these items were $86. So again, I know I've got another equals, and this is going to be 86 bucks. And so this equation has to do with the money. And so I see tacos are $2 and burritos, each one is $1. So right here, my tacos are $2 for every taco sold, and burritos are $1 for every burrito sold. So right here, we have ourselves a fancy little system. And so our job now is to determine, am I going to graph it? Am I going to use elimination or substitution? I think you could use you could use substitution if you wanted to isolate a variable on the top, but I think this would work really well for elimination. And so for me, I see the T's. I've got a 1T and a 2T and a 1B and a 1B. I think the easiest would be to make one of our burritos a -1. And so to do that, I'm going to have to force multiplication. So I'm going to take everything in this top row and I'm going to multiply it by a -1 because I want this burrito to be a -1 so that it cancels out with a +1 below. So equal share, equal share, equal share. Every term is multiplied by -1. Now I'm going to write the new equation below. Turns into -1t minus 1b all together equals -48. Now, I'm going to use these bottom two equations to set up and use my elimination. Okay, so right here, I'm just going to draw my line, and I hope you see that the b's cancel. And look at this, 2t minus 1t gives me just t for tacos, and I get my answer pretty quickly here. So my tacos turn out to be 86 minus 48, which I believe is a 38. So my solution, I'm going to say t equals 38. Okay, so I've got my one variable, and we'll explain what that means in the next step. But if I know that the tacos are 38, I'm going to come back up here and I could use any one of these equations, but t is 38, so I think I'm going to plant a 38 right here where the t is. So 38 plus what gives me 48? Well, I can tell that the number of burritos has to be 10 because 38 plus 10 gives me my 48. I just went 48 minus 38. So the number of burritos must equals 10. Okay, now to explain, I think you literally would just write 38 tacos. That is what this sale means. So that there's 38 tacos and there are 10 burritos. So just being thorough on explaining what does that mean, and that's it. I hope this video has helped you and is helping you prepare for our systems test coming up on Thursday. Have a great rest of your day.